Hey everyone, my name is Adam Dixon. Welcome to my channel. Today we're going to be talking about gradient descent. Here's some woodworking like always in the background. So, in our last video, we explored how neural networks are structured, covering input layers, hidden layers, and output layers. But today, we're diving into something even cooler. How neural networks actually learn. We'll break down gradient descent, backpropagation, and how a neural network can recognize handwritten digits. Let's get started. So, quick recap. Neural networks are made up of layers of neurons, each connected to the next. The input layer takes in the data, hidden layer processes it, and the output layer gives us predictions. But how does a neural network get from random guessing to actually making accurate predictions? That's what we're learning comes in. To see this in action, look at a classic problem. Handwritten digits recognition. We train a neural network to recognize numbers from MNIST dataset. Each digit is represented as a 28 by 28 pixel image, which means we have 784 input neurons. In our setup, we use two hidden layers, each with 16 neurons, and an output layer of 10 neurons. One of each digit from 0 to 9. At first, the network starts with random weights and biases, which means it performs pretty badly, but that's expected. So how do we measure how bad our predictions are? We use something called cost function, which tells us how far our predictions are from the correct answers. Our goal is to minimize this cost as much as possible. Enter gradient descent. The magic behind neural network learning. Imagine our cost function as a hilly landscape. We want to find the lowest valley. Gradient descent helps us do that by calculating the slope and adjusting weights and biases in the right direction. But how do we know which weights to adjust? That's where backpropagation comes in. It's a super efficient way to compute the gradient and update all the connections in our network. We'll cover that in detail in another video. With gradient descent and backpropagation, our network gradually improves. Eventually, we reach about 96% accuracy. With tweaks, we can even push 98. But here's something surprising. The network doesn't always learn the way we expect. Instead of recognizing edges like humans, it finds other ways to classify digits. Sometimes the way AI learns is completely different from our intuitions. And that brings us to a major limitation. This network isn't truly understanding digits. It can be easily fooled by random noise because it's only as good as its training data. So AI is powerful, but it's not perfect. Want to see this in action? Try building your own neural network. Experiment with different architectures and learning rates. Anyways, thank you very much for watching this video. And make sure to check out the channel for more educational videos. Bye-bye.